Thank you for joining us for ShipIt number 17, Deleting the Undeletable. ShipIt is our monthly virtual gathering where we bring together engineering shop folk to talk about the things they're working on and take questions from all of you that have decided to join us today. My name's Anita Clark, and I'm the Senior Managing Editor at Shopify, and I run Shopify's engineering blog. Today, we're talking about how Shopify's privacy and data science teams came together to build a platform to safely manage personally identifiable information, aka PII. I'm welcoming two senior members of the privacy and engineering team to talk to us about this effort. We're taking questions at the end of this presentation, so please use the Q&A mode in the chat to ask. Welcome and thank you, Behrooz and Jason, for being here. Really excited to see your presentation. Thanks.
Hello, everyone. My name is Behrooz, and I'm a privacy engineer at Shopify. So today we're going to talk about a metamorphosis in our data analytics platform, in particular, how to make deleting the undeletable possible. So I'm sure most of you are familiar with Shopify, but if not, we are a global commerce company with more than 1.7 million merchants of all sizes all around the globe. We've had more than $300 billion worth of sales on our platform. And as you can imagine, there's a lot going on this platform. And in fact, we collect a variety of analytical events from our merchants and buyers to improve our own platform and also help our merchants with their decision making. So here's how our analytical platform used to look like in the past. We had different type of events getting fired from all across our platform. Things like sign up, a new merchant signs up, point of sale transactions, or checkouts. They would then go through our messaging pipeline, Kafka in this instance, and they would get persisted into our data warehouse. And that's where our data scientists could analyze and run jobs on these data sets. And you may be wondering, why am I telling you about this? And it has to do if you take a closer look inside our data warehouse. Oftentimes, these events contain personally identifiable information, or PII. And we had obligation to act and find this personal information upon request in an efficient manner. And this turned out to be a very challenging task, and at least a lot harder than what we initially thought. And that was because our data warehouse was designed to be immutable by default. So that meant once the data entered data warehouse, it was very difficult to change or delete it. And most of these events were collected in an ad hoc manner with no guaranteed structure. And that meant, except the person who created these events, nobody knew how to parse or read them, so they were essentially binary blocks. And next, they had their privacy context missing, and that meant even if we could find personal information, so for example, an IP address, we couldn't say to whom it actually belonged, like what data subject owned that piece of PII. And a lot of production jobs and dashboards were depending on this data set, and any change could cause cascading failures. And last but not least was scale, both in terms of the data, this was petabytes of information, and also hundreds of people were depending and using these data sets. And it wasn't just these challenges, there was a lot of maintainability costs and other issues that data team had with these data sets as well. So it kind of brought up a natural and golden opportunity for us, the privacy team, and the data team to work together and address these issues. In the rest of this talk, I'm going to tell you about our collaboration with data team and how we address these challenges. Our first step was context collection, and that was because we believed that missing context was the root cause of a lot of the problems that we were facing. For context collection, we introduced a new schematization system, and you can see an example of a schema for an event, sign-up event in this case on the right side. Let's read through the schema and see what kind of information and context it collects. First, its structure. All events all fields in a schema now have a concrete data type and a short description describing what are they. And next, we have versioning information. So over time, once these events start to change and evolve, we capture that via our versioning system. And last and most importantly is privacy context. So every personal field in this schema is tagged as such. And you can see, for example, here we have an email and IP address that are marked to be email and IP. There's also some privacy handler tag that says what to do with this personal information that we'll talk about them later. So we talked about tracking and finding personal information using these schemas, but we actually haven't still addressed how to delete the information in our data warehouse. And for that, we decided to actually not have any personal information in our data warehouse. So that sounds kind of counterintuitive. And if you don't have any personal data there, we might be losing analytical value. So let's see how that makes sense. So to do that, we use what GDPR calls pseudonymization. So pseudonymization is processing of personal data in a manner that no longer can be attributed to a data subject without using additional information. In particular, we use two types of pseudonymization, obfuscation and tokenization. So in obfuscation, identifying bits of data are masked and removed, and it's an irreversible action. And that means, for example, for an IP address, half of it gets masked. Or for user agent, all the identifying bits like fonts or resolution or clock skew, they all get removed. But we also enrich these type of personal information with aggregate level data that most of data scientists were after in the first place. So for example, for IP, we geolocated, and for user agent, we extract high-level information like device or operating system. And these are actually most important information that most data scientists needed. So even though obfuscation solves a lot of problems and addresses a lot of use cases for our data scientists, there remains cases that we still need access to the raw value of personal information. And that's what tokenization is for. So in tokenization, the raw value of PII is exchanged with a consistent random token. And this consistency is a key property. And that means if you see the same personal information, you're going to get the same token again and again. And these tokens are exchangeable for the actual PII value. So this was a lot to process. Let's see an example of this pseudonymization in practice. So again, on the left side, we have an example of a sign-up event, and we have an IP address, an email address, and we built this tool called Scrubber that applies pseudonymization on these events. So IP address got masked and geolocated, and email address got masked, so its local part is redacted, its domain part, because it's popular, gmail.com remains, and it also got tokenized. So every other time we see this email again, it's going to get the same token again and again. And this is the consistency property that I talked about earlier. So how does this help? If you think about it now, we end up with three kinds of data in our data warehouse. First is non-personal data, things like IDs or timestamps. And next is obfuscated data. We'll talk about it earlier. So in these two groups of data, there's nothing personal anymore to be deleted. And there remains the third category, tokenized data. So tokenized data, if we figure out deletion for tokenized data, we're kind of good to go. Although it's important to mention that data that has gone through pseudonymization, as long as there remains a way using additional information to be re-identified, it is still considered PII. So we're not completely 100% removing the risk here, because there always still some re-identification test, but it's significantly reduced. So to understand tokenization, here we go through an example. We have a buyer named Human who has two favorite merchants, Allbirds and Gymshark. And you can see Human's purchase history from these two merchants. And we're going to apply tokenization one row at a time to this table on the left and see how it works. So first we take human@gmail.com, the email, and take it to the tokenization vault. And because tokenization engine has not seen this email under this controller or merchant, it will just generate a new token, token 123, and returns it. So token 123 gets stored in the original table. So next, we again take the same email and send it to the tokenization vault. And even though it's the same email, it generates a new token. And that's because the merchant or the controller is different. First time it was Allbirds, now it's Gymshark, so it gets another token. And token 456 gets persisted. And lastly, we get again the same email, same buyer, and it goes to the tokenization vault. And this time, it does not generate a new token. That's because the merchant is Allbirds already, and we already had one row, the first row in the tokenization vault with the same information. So the data subject was the same, the controller was the same, hence the token is the same. So you can see how the consistency property works and how one can use that to track a data subject without actually touching and having access to the raw PII value. So this is how tokenization works. But we need to understand, okay, now we understand tokenization, how does deletion work for tokenized data? So for that, we are again going to a similar practice and we go through some imaginary deletion requests from human. So let's say human first request to be deleted from Gymshark. So all we need to do in our tokenization vault is to set the data subject to human at gmail.com and the controller to Gymshark. So this will result in the two middle rows. So if we delete this association, essentially everywhere else in the data warehouse that we have token 456 and 789, they will never be able to be exchanged, and it's essentially deleted. So they become random values. Similarly, human can send a deletion request to be deleted from all merchants, and all we need to do is set the data subject to human and the controller to a wildcard. And it will result in the first three rows. And once that's gone, essentially human is gone from all merchants. And last but not least, we could use the same trick for when a merchant departs Shopify and essentially what we call a purge process. So here in the unlikely event that Gymshark wants to leave Shopify, all we need to do is set the controller to Gymshark and the data subject to wildcard. So this will delete all the data that is controlled by this merchant. So you can see in all of these operations, we did not do anything in the data warehouse. We did not do any search. We did not change anything there. And all of these happened in the tokenization vault in a fraction of a second. So you can see how we achieved deletion of PII in a very efficient manner. Last but not least, this also allows us to introduce automatic retention should we need it, even without having a request on this personal information. So putting all of this together, this is how our analytical platform looks like these days. So again, we have our analytical events getting fired from across the platform. In this case, a sign-up event, it goes through Kafka again, and then Scrubber Tools looks up the schema for sign-up event and uses that to figure out what kind of PII is in there. So it obfuscates them, and then it figures out some fields need to be tokenized. So it takes raw PII value and sends it to the tokenization vault. So tokenization vault sees the PII and generates a new token, or maybe returns an existing one. And once it's returned to the Scrubber replaces in the event, and the obfuscated and tokenized event now gets persisted into our data warehouse. So are we good yet? Yes and no. So we figured out a sound technical solution to this problem, but it turns out having it rolled out and having it done at a big organization like Shopify was quite challenging. So we learned a lot of lessons that we think are useful to share with you. First was adoption. So this was a lot of changes. And if you take all of these changes and propose infrastructure to a team and an organization, this is probably the reaction you're going to get. And that's rightly so, because this is kind of like open heart surgery on our entire analytical platform. And next was addressing historic data sets. So this infrastructure would solve our problem moving forward, because it will only work on newer events that were coming in, but we were still sitting on petabytes of information and historic set that needed to be processed. So for the problem of adoption, we realized that proving the accuracy and scalability of our tooling was key. So we used the very same techniques that the data team used to show the what they call reconciliation and accuracy of our data set. That the scrub data set are essentially the same thing, and they only have obfuscated and tokenized fields different. So there is nothing new or missing. And we also went several order of magnitude higher than normal load to show that this infrastructure is able to capture load at scale. So this helped to bring trust into our tooling quite a bit. And next, we found that making the right thing the default and the easy thing to do was very important in adoption of our tooling. And once the right thing is the easy thing to do or the default thing, then people are actually very willing to respect privacy and do the right thing. And similarly, making the wrong thing the hard thing. So for example, these days, having an unstructured Kafka topic or events is a very hard thing to do at Shopify and requires several levels of approval. So essentially, there is no motive or a discouragement for people to go that route. And last but not least, we brought new value. So oftentimes, security or privacy might be considered as bringing limitation, but actually quite the opposite here. So we brought a lot of new automation and integration with query tools, or as I explained earlier, we enrich data with aggregate level information that most data scientists really need and use in the first place. So there was a lot of motivation to use this data set because they had more value than the raw values. For the for the challenge of addressing historic data set, we found that having organizational alignment was key. So that helped us to have a consistent messaging. And once we had that from our senior management, then it was only a matter of working with different teams and having it as a priority and working with their deadlines as opposed to whether we're going to do it or not. And that really helped us to move the needle forward. And another important factor was having a dedicated task force. So teams change, priorities change, people change, but having a dedicated task force that progresses and monitor the progress and pushes the needle forward, even so small, was a very important factor to not let this kind of work die. And that's because this kind of work takes forever, and that's just because the volume of data was so high. So having someone that constantly keep an eye on the progress was very important. Lastly, we found that reducing the amount of manual labor via automation and tooling helped us a lot, and as well as documentation and providing support when there was like slowdown or tools were not catching up enough. So all of this helped to push this effort forward. So we have been running this infrastructure for more than 2 years, and it handles between 500,000 to 1 million events per second on busy days. And we handle 10 to hundreds of millions of deletion per day. And it took us almost 3 years to develop, roll this out, and reprocess most of our historic data set. So today we have more than 500 billion distinct PII stored in our tokenization vault, and we reprocess more than 100 distinct data sets on order of tens of petabytes of information. And more than 94 individuals contributed to this project. So all of this to say that this infrastructure and these proposed changes are working in production in real world at scale. And it was a massive effort that took help from various teams and peoples that contributed to this project. So in summary, we learned that unstructured data is evil and it causes a lot of maintainability, privacy issues, and it should be avoided. We learned that pseudonymization, in particular tokenization and obfuscation, are very useful tools for handling personal information in large-scale data sets. And we also learned that solving technical challenges is very different from addressing organizational challenges, and they remain to be separate issues that needed separate care and to be addressed. With that, I would like to thank you, and Jason and I here to answer any question you may have.
Awesome. Thank you Beiruz, for that great presentation. Jason also. Okay, so let's start with the question. So the first one kind of goes back to your multi-controller tokenization slides. And Jason is asking how token 123 linked to token 456, as they are both linked to humangmail.com.
Even though the data subject, the human, is same here, but legally these are two different entities, and that's why token 123 and token 456 are actually different things. So human, in eyes of law, has actually two data subjects, is considered two different data subjects here. Because first is legal relationship is with Allbirds, and then the second one is with the Gymshark. And that's because, if human sends a request to be deleted, and if we didn't have this concept of controller and this distinction, essentially, if we would have deleted human, then we would be deleting it for all merchants, and that's not the outcome that we are looking for, nor for human, nor for neither for our merchants.
Yeah, that's a concept specifically from privacy. In this context, Shopify is providing a backend service for both Gymshark and Allbirds, and the consumer doesn't know that either one's running on Shopify, so they don't ask Shopify to erase them. They ask the merchant to erase them. The merchant has to press the button to do it. And so when we do that, we have to respect that we delete them only from the merchant that requested it, and not delete them from the merchant who didn't. And that's why we have to treat them almost as two different people. So they are the same email address, but in our system, intentionally, they're treated as if they were completely different people.
Does the tokenization vault that converts PII to tokens store PII, or is it just removed, or is it removed after the tokenization process?
Yeah, so the PII is stored alongside with the token, as long as there is no deletion request or a retention policy. And that's because, remember, we said that there's cases that we want actual value, access to the raw value of PII. And, when we get the token, a data scientist might ask for the raw PII and we exchange it. So we do have the raw value as long as, there has been no deletion request. But once the deletion request is there, then we remove the raw PII value. And even if we get the request to be detokenized, it just results in a null or redacted.
Does the scrubber send data to the tokenizer repeatedly? And if so, isn't that kind of slow?
Sure. This is a great question. This is something we encountered really early on in our development of it. That we're sending data over to Google Bigtable, and on every request, that's a round trip that causes us to be really slow. Fortunately, the API for us to use Bigtable has a bulk process, which allows us to send thousands of requests simultaneously, and so that way the request can still take half a second to a second to complete, but it's doing thousands of requests tokenization at the same time. So our tokenization system we have here is built for throughput, not latency. So one request might take half a second, but on average, thousands of them take the same half a second. So on average, it's very fast.
Next question is, you mentioned that you brought new value with automation and tooling. Have you seen better adoption of some tooling over others? And how can smaller organizations triage what will have the larger impact?
Yeah, I think some of the tooling. So for example, now when you create a schema, so you automatically get links to here's how you would query the data that's, for this event or for this topic, what we call it. And, you automatically can see loads or some metrics. And, typically all of these would require quite a bit of work to get set up, but now it's all free just because you have a schema. And for the second part, how can a small organization triage what will have the larger impact? I'm not sure actually if I understand that part of the question. Do you want to talk about that, Jason?
Sure. I can say that I think the obfuscation that we actually did that first, and it had probably the largest impact. Just making these tools available for anyone to use to extract some analytical value in a privacy-friendly way automatically drove the greatest adoption. And in particular, what Barry's talked about, I think he undersold it, the IP address and the user agent string parsing. Almost all the data sets we looked at were our data scientists were looking at the IP address. They were invariably just running it through a library to geolocate it to get to the city that they wanted, like the state, and that's all they wanted. And because we did that for them on the front end one time, they didn't actually ever care for the IP. Like the IP address on its own is actually fairly useless for most cases other than that. So doing that kind of obfuscation work was a relatively low lift. It doesn't require any permanent storage. It's runtime. It can be. We do it in very little amount of time. I think that's where I would start in a small organization, is adding some sort of privacy-friendly, value-added obfuscation.
How do you keep an audit trail of any deletion requests in case you need to prove this during an audit from regulators?
Yeah, so we have a whole different system and infrastructure for keeping track of this request. And actually, our whole tokenization vault is just one system that the other system talks to. So because the Shopify, there is multiple different systems that hold data. That central entity that keeps track of this deletion request essentially has a record for everything that, this subsystem, for example, tokenization vault, did it fulfill the request or not? And it's all recorded and kept track of.
Do you have any advice on how to present a privacy project like this to senior leadership to get buy-in?
Sure. So we actually made a big mistake on this one the first time. We started by going with trying to get low-level support first and try to build upwards from there. So we got low-level buy-in support from like the individual contributors and the first level of managers, but it was such a massive effort that it inevitably started impacting like deliverables and timelines for other projects, and that's when senior leadership and our executive team put the brakes on everything and said, "Hang on, stop! We got to rethink this. We got to make sure we all are aligned on this." And so then we had to go back and align with senior leadership. So my advice would be to sanity check and check in with the individual contributors and make sure you're proposing to build the right solution to meet their needs, and then go to sort of senior leadership to make sure that they also agree this is a priority and we should do this, and this is the right time to build that, and understanding with eyes wide open what the impact's going to be on the rest of the organization.
Any kind of things that people should focus on when they're delivering that pitch, besides adding value and all that kind of stuff? What else is important to getting this many people to say yes to something that's going to take a fairly large group of people and time to complete?
First, an estimate of at least your best guess of how long it's going to take, a clear statement of what it is you're going to achieve, what is the problem, with examples of what the current problem is, because most people, executives that aren't up on privacy, they don't know the details, the ins and outs. You have to explain what the issues are. They want to solve the problems. They want to do the right thing, but they need to know what those are. So explaining what the problem is, explaining your current situation, describing the specific change you're going to make, an estimated timeline, and a number of people needed to make the change. And then it's simply an executive call to decide, is this something we take on now? Is this something we wait for the future, or is this something we just want to roll the dice on and just hope we don't get caught? That's ultimately, that's not a approach I would recommend, but that's definitely always up to the executive branch, and it's unfortunately a choice that some companies make.
But not Shopify, of course.
But not Shopify. No, we definitely want to respect our user privacy.
Great. Okay, our next question is: have you come across any scenarios where you had to deal with conflicting requirements to satisfy different legislations, GDPR versus CCPA, or even if they're not conflicting? Let's say two legislations have different retention periods. Hypothetically, let's say GDPR has 3 years of retention and CCPA has 5 years, and a customer is shopping globally and falls within the range of the scope of both of those regulations for two different Shopify merchants or the same merchant service across border use case. It's one question, but it's also in the chat. If you guys want to take a look and read at it there, it's pinned. Thanks, Rocky, for this question.
I can take that one, Beers, if you want.
Sure, go ahead.
Yeah. So no, to be not really, to be blunt. We take the approach as much as we can at Shopify of taking the most strict regulations and trying to apply that globally. Generally, that means GDPR, although other new laws are coming in that change it. And we do our best at applying a sort of common policy across all of our users and all of our merchants. Obviously, there's some exceptions to that, but generally that's our approach. There are some very specific things around like the opt-out of sale in California, et cetera, that do require some specific solutions. But those tend to pertain to where the user is, not to where the merchant is. And so if they're physically in California, CCPA applies. If they're physically in Europe, then GDPR applies. So we don't really usually see many conflicts in that respect.
Yeah, I was going to add just, for example, when GDPR came and built all of this stuff, even though in Canada, for example, we didn't have this regulation and requirements, but once we built it out, it's just also technically it's easier to apply to all, and as opposed to having it, specific to, say, European users.
Can you talk about how you approach SAR, subject access request queries from customers?
I think, we call it data subject request, but initially we have a system that, intakes this request. So it requires, authentication. We make sure, this is the actual data subject. It might require, you show some sort of ID or something like that. And then once, that has gone through our legal doors, then it comes into our central system that keeps track of deletion requests or access requests. And then it's from there, it's kind of disseminated between all other different data store or systems that at Shopify store personal information. And that central entity essentially keeps track of what subsystems have, fulfilled the requirement, or, for example, if it's a deletion, have they deleted completely all the information or not? And, once the whole thing is done, then it communicates back to the users or the customers.
Yeah, we really rely on a lot of automation for this. We have a lot of services at Shopify with personal information that all talk to each other, and so there's a mix of manual process for some of it and automation wherever possible, especially for our more common systems. It's a mix of both, and we have a centralized sort of privacy orchestration system we've been building that's separate from the systems that Beru's been talking about, and it handles the erasure and access requests, both notifying services to erase, that you're supposed to erase a certain person, and also that information has been requested, and the servers are supposed to respond with that information. Now, of course, it also makes a difference whether we're talking about our merchant's customer, the merchant is telling us to do something, or whether the merchant themselves is filing an access request. Those are, of course, two very different processes, because in one case we're a controller, in another case we're a processor.
How large was the dedicated task force, and how does the team work across Shopify? Do they work with other teams to build these systems?
Jason, do you want to talk about this?
Sorry.
Sure.
Laughing.
No problem. Yeah.
Well, he's the manager, so he can talk about it.
I know. I was laughing about that.
The dedicated task force, it changed in membership. Beru's mentioned 94 people. That was like over the 3 years. So the membership changed a lot over the years. Certainly there were some core members on our side, myself and Beru's, for example, that were like a core part of it throughout. But even towards the end, we didn't have that much to do because the infrastructure was all there. So the team was, on the other side, there was typically a core membership of 3 or 4 people on the data side that were coordinating everything, and then they would basically find like this particular data set, or these data sets need to be reprocessed, and they would assign tickets to the respective owners to reprocess them. So on most members were involved for only a few weeks at most, reprocessing one specific thing. The core team is probably a half a dozen or so throughout, and again, membership change throughout.
Do you offer deletion or data subject requests for Shopify users in a self-serve manner from their accounts?
That's a great question. Yeah. We're working on that. We're trying to do that. We very much would like to do that. At the moment, no. But it's something that we definitely want to improve the whole process around deletion and access requests, for sure.
Yeah, I think I was going to just say, to clarify, Shopify users could be different thing. Like, are we talking about the merchants? I think those are direct users, and there's also buyers that we may or may not have a direct relationship with. Typically it's through merchants, but there may be some cases. So for example, when they use ShopPay, that we have a direct relationship with.
Yeah, it's a good point. Actually, Shop app users, I forgot about Shop app users. To delete yourself from Shop app, yes, you just go to shop.app/opt-out and fill it in there and your account's deleted and everything's erased. Access is a little bit more manual. And as the other side, our merchants' customers, our merchants can request erasure or access directly from their admin for their customers, but not for our merchants themselves. We still have a manual process for that for our merchants and partners.
Okay, great. So to sum up, merchants, yes. No, merchants is manual. Customers to merchants, automatic. They can request to us. And I don't remember what the last one is, but I'll just leave it at that.
Shop app users.
Shop app users.
Automatic,
direct connection with us. That's automatic.
Yeah.
Awesome. Okay, next question. How do you apply this to merchant logins and merchant PII? Is it a similar process?
I'm actually not sure what do they refer to by merchant logins. You know this?
Yeah, probably talking about their merchant when they sign up to Shopify, their account. Yeah, that's what I'm talking about when I'm talking about our merchants. The merchants can apply to us directly to have their information erased. That's absolutely something that they can do. The process itself isn't fully automated. They can't do it right from their account yet. There is a website to go to. It's at legal.shopify.com to submit a request. It's more manual process than I would like at the moment, and it's something we're definitely working on improving, is to make that a lot easier to do that in a self-serve manner.
Why do we need the controller concept in the tokenization scheme?
I think we talked about that earlier, and that has to do, because we are here on behalf of merchants, so we need to be very careful about where and what merchants we delete information from, because typically buyers have a relationship with merchants. So even though, in my example, for example, Human was the same person, but they might be shopping from, multiple merchants. So we need to be really careful from, what merchants we are deleting this information from, because otherwise we might have very angry merchants and buyers.
Yeah, you can imagine how angry someone would be if we started deleting their customer list from them just because they requested erasure from some other totally different merchant. That wouldn't go over very well.
How do you determine what fields to tokenize or obfuscate?
Yeah, so when a new schema is proposed, we have a series of automated essentially tests that try to figure out what is personal information, what is not. It's a combination of using ML models and regular expression, things that we have seen quite often in the past. So this is the automated part that says, for example, hey, we think this is probably personal information. You haven't marked it, but that's just, a second factor. All of the schemas are actually reviewed by a member of our team and are human reviewed. So that automated part makes it easier, but typically it first starts by the person who creates the schema. So they try to figure them out automatically. Then there's automated tests. And then as the last resort is the privacy engineer who will approve the schema.
That was actually Behruz's last Hack Days project. He decided over Hack Days a few months ago to just throw together an AI to figure out if something's PII or not, which was a great, very welcome addition to our manual review process. It's made a big difference.
Oh, that's cool. Was it is it being used now, or was it?
Yeah.
Oh, wow, that's cool.
It's
nice to hear those stories.
It's actually automatic. It's integrated to GitHub. It just reads the pull request and automatically responds back as a comment in the GitHub pull request to let them know that, hey, this looks like PII. We could be wrong. It lets very clear this is just an automated check. It could be wrong, but just FYI, this looks like it could be PII. It's a very neat system he wrote.
Oh, that's great. Okay, next question is, what is the biggest challenge the privacy team faced during this rollout and just build also?
I mean, it was all big challenges, but personally, for me being a very, technical focused person, it was really hard to get that adoption going on and just convincing all of these people that this is the right thing to do and it makes sense to do. So that adoption part was really hard. But I think also, going through that years of historic, that was another big challenge, I would say.
Getting everyone to buy into this thing, communicating to everybody. This is going on top of your question. What did you learn? What new techniques did you learn to make this happen? Because obviously it did, and you must have grown during the process. What things can you let people know to take away from your experience in that
I think
that long process?
Yeah. My people skill definitely increased significantly in this project. One thing that I think is very important and useful is talking the same language. And talking the same language here meant, for example, we think this tooling is great and it's going to work, but for example, people of data, this meant nothing because they understand, for example, this process called reconciliation, which says, okay, you're telling me your tooling is accurate and working as expected, but how do you actually prove it? So once we started using their tooling, then we kind of had a common language and a common understanding. So that was really helpful. And I think the other thing is that was very useful, and I tried to mention it, was going after specific checkpoints that people have a decision, and if you make that decision the easy thing to do, and that easy thing is the right thing to do, then essentially you're having, everyone's buying kind of automatically. So for example, once we made the schema as the default thing, then kind of people started adopting this automatically, without, going after them one by one. So I think these two things are quite important.
I'd echo Behruz's points that the biggest challenge was definitely the organizational part. The tech part was great. We were able to just knuckle down and solve the technical problem, and thought, great, we're done now, right? And that was the first third of the project, was that. The rest was dealing with the people, the historical data, and just getting alignment from the team. That was our biggest failure in the project, and unfortunately we were able to recover from that.
Now, dealing with historical data, and there's lots of it, seems like very tedious kind of thing. How do you motivate teams to keep on track, to just plow through it and see that light at the end of the tunnel? Because I imagine there's it was probably some dark days going on with some people during this.
Oh yeah.
Yeah. I have a few points, and then Jason can add to them. I think having that dedicated task force was very important. So we would meet weekly, us and a few people from data, and essentially we had this beautiful spreadsheet that kept track of, okay, these are all the job. Every week we would make some progress, and we had this graph. Oh, there's 300 days left, then it would be 100 days left, and then sometimes you would just see, oh, this is stalled and not moving anymore. So that task force would be, super helpful. Okay, why is it not moving? Maybe we need to add more machines, more humans. Maybe this team is preparing for BFCM. So essentially, finding the bottlenecks, right? And this was kind of hard because, a lot of the time we were waiting for machines to do the job, and there was not just much we could do except waiting. But having that team to constantly monitor it was really helpful. And I think also, once we had the buy-in from the senior leadership, it just was not a matter of, okay, are we going to do this or not? We were going to do this, but it was just a matter of, okay, how do we fit this in various team schedule? Because like I said, different team had different priorities. Maybe we were near BFCM, so we kind of need to work with their schedule. And it wasn't a matter of whether we're going to do this or not.
Yeah, I'd add on to that it was we were really fortunate as well that we got some people in the data team who knew the ins and outs of what needed to be done. They were much more familiar with their systems than we were, and they were super organized. So Trish was super helpful on our side. She worked in the data team. She was unbelievably organized with like Miro maps of like all the data sets that need to be processed, aligning teams, creating GitHub issues. So project management on something at the scale, navigating multiple teams was absolutely critical. And we were so lucky to have someone on the task force who was skilled at that. I learned a lot from her, but she's still a lot better than I ever will be.
Mm-hmm. Yeah, I remember she had like this crazy dependency graph that, like there was 100 nodes here, and then, because you had to do this job in a manner that it wouldn't break production jobs, and that required to go at the bottom and try to build it up slowly all the way to the top.
Yeah,
sounds like a lot of planning, a lot of detail.
The other part that really helped was being able to show regular progress. So we were able to latch progress and say, okay, this part of the project is now done. We can remove that from our mental mind space of like, that we don't have to work with that anymore. This part is what needs to happen next. And even then we were able to like cross things off one thing at a time. So being organized and being able to visualize, the progress you're making was a huge boost to our, mental capacity when we were feeling down and about a 3-year-long project.
It must have been the hugest party when this thing went off.
I wish, but it finished in the middle of the pandemic, and so like
I was gonna ask if it did or not, and yeah, that's too bad. I'm sorry.
We were able to really get together and celebrate, but we definitely called out everybody that helped out. It was a huge booster, and doing things like this where we're calling out and making it known what the team did, because it was really a great accomplishment. So that helps as well.
Awesome. Oh, there's a question for me.
For you?
Yeah. When from Rocky, when you use this format versus Twitter Spaces format, depending on content and need to show slides or something else. That's interesting. I haven't really used Twitter Spaces, to be honest. I don't know. It's just like audio, and I feel that the video's nicer. And this format, we can save this recording and share it with other people afterwards. Twitter Spaces kind of just is like an ephemeral type of thing. Like you're either there when it happens or not. And I get that for some people, but I'm more focused on letting the widest audience see this information and learn from our developers and learn about the projects that we're working on. So that's kind of like the differences between this. We are doing stuff on Spaces, and that does happen. I don't run any of those things. Thankfully, I have enough to do, but it also is a really great format that some people enjoy. So, we like to be where people are and engage them on the platforms that they want to engage with us. So we're experimenting all the time with things, and we'll be experimenting with ShipIt too. Like, we want to do different things with the format and change it up. Okay, awesome. So if anyone has any other questions, because we have 5 minutes left, if you have any pressing questions, put them in the chat. I'll give you a moment to do that. But otherwise, I want to thank Jason and Beirut for being here. Hi, Eamon. If you see in the chat, Eamon, our social media manager, is talking about, just basically saying, I'm right.
That's always reassuring.
I'm right all the time. So if there's no more questions, I want to thank everyone that joined us today. There will be a recording of this presentation. It'll be shared on social by Eamon, and it'll also be emailed to all the registrants of the webinar. We want to remind you that we're hiring. Check shopify.com/careers. There's lots of openings all over the place. Any privacy-focused openings that they should be looking for on that listing there?
I'm interested on the listing, and obviously we'll be hiring more privacy engineers sort of next year. For sure, we're going to be growing the team. I believe we're still looking for someone with engineering management experience as well. So anyone who's a dev manager and interested in privacy, privacy expertise is not a requirement for any of these roles. No one on our team had privacy expertise coming into this, myself included. Obviously, related experience helps, but really we're a dev team, and we take developers and we train people up on the privacy side.
Oh, that's great. Thanks for that information for people. So, it's not as like glass walled that you can get in there and learn. And, Shopify is a place for learning. So as long as you have an appetite for learning, like we're interested in hearing from you. And on that note, join us next month on the 27th for another ShipIt that will also be security focused. And have a great afternoon. Thanks.
Bye.
Thanks, everybody.
Bye.